Good afternoon, students. We'll start with our today's lecture. So, in the last lecture, we had completed this solution, and how we found out that solution I had explained. So, now we'll see one example with these two vectors. So, they have taken two vectors r is equal to 2 minus 3 4 and s is equal to 5 6 and 10. So, when I calculate magnitude of r, I get the answer with the calculation, that is 5.385, and magnitude of s is equal to 12.689. Therefore, when I multiply magnitude of s into magnitude of r with cos beta, I get those values same. So I'll take the same values, that is 2 into 5 plus minus 3 into 6 plus 4 into 10. That is, they have cross multiplied 2 into 5 plus minus 3 into 6 plus 4 into 10. The common levels, that is 2 and the 5 is the first level, minus 3 and 6 is the second. So they have multiplied and then added it in the each level. So they get an answer is equal to 32. But my answer for my magnitude of s is 12.689. So 12.689 into magnitude of r is 5.385 into cos beta, I'll keep like that only, is equal to, what answer did I get of all these three? That is 32, is equal to 32. So I'll separate cos beta, that is on the third level line. So cos beta is equal to 32 upon, that is, I change the denominator to numerator. When I am taking a value outside my equal to sign, I am changing the position. That will, numerator will be changed into denominator and denominator will be changed into numerator. So I get an answer after all the multiplication, that is a division, that is 0.468. So when I separate beta and I make here cos 1 beta is 0.468, but when I replicate it on the either side of the equal to sign, I'll get cos minus 1 0.468. I get an answer, that is 62.1 degree. The angle between two vectors is 62.1 degree. If you do the calculations, you will get these answers. The values are correct. Next is the dot product in lighting calculation. So Lambert's law states that the intensity of illumination on a diffused surface is proportional to the cosine of the angle between the surface normal vector and the light source direction. Means what? Suppose I have an image which has an lighting from the above side. Sometimes the image can have an lighting from the beside, that is either right hand side on the or the left hand side. So the source of direction of light to calculate with the illumination, that is the level of light brightness and the diffuse surface on which surface it is falling. To calculate this, we have the dot product in lighting calculation. This arrangement is shown in the figure below. That is, the light source is located at degree 20, 20, 40, and illuminated at point is 0, 10, 0. So these are the values what they have given. That is, the light location is 20, 20, 40, and where they have illuminated the starting position 0, 10, 0. So in this situation, we are interested in calculating cos beta, that is the illumination, which is when multiplied by the light source intensity gives the incident light intensity on the surface. So by calculating this, what we are getting the intensity of light when it is falling on the actual image, that is the surface of the image. To begin with, we are given with the normal vector n. So we are obviously doing a vector calculation. So we are given a normal value, that is vector n, to the surface. So on the surface, the value can be of these surface, lighting is n. In this case, n is a unit vector. So n is a normalization vector, that is unit vector, and its magnitude is 1. So magnitude of n when falling on the surface is 1. So when it is falling, see, you can see the light source when traveling is S, as it is forming a angle, it is beta, that is cos beta, and when it is touching the surface, that whole angle is given the value as equal to n. When we calculate the value, it is n is equal to 1 as per the Lambert's law. That is the intensity of illumination when my image surface light falls on the image light falls on the surface of my particular screen. At that time, what is the intensity, what angle it forms, and what name can be given, and what is its magnitude. So when we are calculating the illumination, that is the surface proportion area value, n is equal to 0 comma 0 1 comma 0. So the difference of light source from the surface is defined by the vector s. So vector, what vector values they had provided here, 20 comma 20 comma 40. So we'll minus those values from the actual intensity what it has. So 20 minus first was 0, 20 minus 10, 40 minus 0. So they have subtracted 20 minus from here these two values, and after separating these two values, what they have done is they have calculated that value. So after we get 20 minus 10 minus 20 10 40, that is the final value here, what we can do is we can calculate the magnitude of s. So while magnitude, what we can do, 20 square plus 10 square plus 40 square, the whole root, is equal to, we get the answer 45.826. Magnitude of n into magnitude of s cos beta, this is the actual formula which we performed, that is the dot lining product. So in that we are multiplying, magnitude of n is already given 1, multiply by magnitude of s, we got 45.826 into cos beta is equal to 10, because we got this whole value is equal to 10 when we multiplied it with both the sides, that is 0 into 20, that is this one and this one. So we got 0 comma 20 plus 1 multiplied by 10 plus 0 multiplied by 40 is equal to 10. And after that, when I take cos beta on the outside the equal to sign, 10 upon 4 point, because 1 multiplied by 45.826 is the same. So 45.826 is equal to, the answer is 0.218 cos beta. We are not taking on the negative side, we are just performing cos beta, that is we just need to check the intensity. So therefore the light intensity at point 0 comma 10 comma 0 is 0.218 of the original light intensity 20 comma 20 comma 40. So intensity when it started was 20 comma 20 comma 20 40, but when it reached the surface of the cos beta angle, it is 0.218 is the answer. This does not take into account the attenuation due to the inverse square law of light propagation. So we cannot say that is this can be performed for inverse law proportion of light, that is once it falls it turns back to the position. This law cannot be applied there. Next is the dot product in backface detection. Backface means the back end image detection when we are doing, how it can be performed. A standard way of identifying backface polygons relative to the virtual camera is to compute the angle between polygon surface normal and the line of sight between the camera and the polygon. So when we want to check for the polygons which are behind the pictures or behind the screen, and for that we need to compute two different values, that is the polygon surface, that actual polygon's back surface which it is acquiring on the screen, and the line of sight, that is when we are seeing that surface, what is the distance or what is the actual line which is being calculated from the camera to the polygon, that is the line of sight. If this angle is less than 90 degree, the polygon is visible. When we are actually viewing it with the help of a camera, if that angle is between is less than 90 degree, then that polygon can be visible. If it is equal to or greater than 90 degree, the polygon is invisible. If it is equal to 90 degree and it is more than 90 degree, then that polygon cannot be visible because angle of direction differs. This geometry is shown in the figure below. Although it is obvious from figure that right hand polygon is invisible to the camera. So depending on the right hand side polygon will be not visible because the camera fixation is not there for the right angle. Let the camera be located at 0 comma 0 comma 0. So the lens which the camera is going to capture is 0 comma 0 comma 0, and the polygon vertices are, so polygon surface vertices are 10 comma 10 comma 40, and the normal vector, the vector value calculated is 5 5 minus 2. So if my normal vector value is n is equal to 5 minus 2, magnitude of n is equal to 7.348. So they have calculated magnitude of n, and the camera vector c is, so they had given an value 0 comma 0 comma 0. So it's a camera located, and the polygons vector was 10 comma 10 comma 40. So they have subtracted it and they got the answer as minus 10 minus 10 and minus 40. So they calculated magnitude of c, that is minus 10 the whole square plus minus 10 the whole square plus minus 40 the whole square whole root. So they got an answer that is 42.426. So therefore, when I multiply it with the same thing for my back surface of my image, I'll have the same formula with same cos beta angle, and when I get that angle, if it is more than 90 degree, so see here its answer is 93.635, that is more than somewhere 90. So the polygon will be invisible because see here the camera lens here is visible and is showing less than 90 degree, then it would be visible. If it is more than 90 degree, it is exceeding the lens focus, and that is the reason it is invisible. Next is the vector product. Now when we are doing vector multiplications, what the vector product is? As mentioned above, there are two ways to obtain the product of two vectors. So first is the scalar product and second is the vector product. So to obtain a particular value, we have two ways of two vectors, that is scalar product and second is the vector product, which is also called as cross product because of the x symbol used in the notation. So we use a multiplication sign, and that is the reason it is also called as cross product. It is based on the definition that two vectors r and s can be multiplied together to produce a third vector t. So by multiplying two vectors r and s, we can get an answer or an third vector after their multiplication, which is called as vector t. So where magnitude of t is equal to magnitude of r into magnitude of s sine beta. Now b is the angle between r and s. Here sine beta is the angle when we multiply, so it's a sine beta angle. Let's define two vectors and proceed to multiply them together. So when we are multiplying these two vectors, r is equal to obviously a of I plus b of j plus c of k, and s is equal to d of I plus e of j plus f of k. So r into s will be multiplying both the components. So we'll be taking first component of the first bracket and then multiplying it with the whole bracket. Then next is second component and multiplying it with the whole one, and again the third one and multiplying it with the third whole bracket. Likewise, we'll multiply each and every bracket, we'll get the answers. I into I, so I or into j is equal to k, j into k is equal to I, and k into I is equal to j as per the vector product. Now this is not I comma I is equal to 0, all is equal to 1, j comma j is equal to 1. It's not like that normal dot product. This is vector product. So he also thought that j into I, that is vice versa, is also k into j is equal to I into k, that is multiplying 2 and getting the product as third one is the actual formula, but this did not work. So r into s, ae I comma j is af I into k. So this is the final answer which we are getting. Because this did not work, this actual formula did not work, and not this one, this one, sorry, this one. So they found out this one as the formula and they inserted these values. After inserting these values, the answer, and after modification, we got that r into s is equal to bf minus ce I minus af minus cdj plus AE minus BDK. So if this is written in the determinant form, we get R into S, B, E, F, C, F. That is B is the first one, C is the first one there, E is the second one here, and F, that is vice versa in the determinant form, minus I minus A, C, F, D, F, J plus A, D, E, B, E. Likewise, opposite side. If I am taking the first one here, I will take the second one there. If I am taking the second one there, I will take the first one. Opposite. And areas of parallelogram is equal to magnitude of T, and area of triangle is equal to half of magnitude of T. So these are the things which are related to your vector product. Now calculating 2D areas, that we'll see in the next lecture. We'll stop here for this lecture. Thank you.